Welcome to Naradar Academy. This video is about Introduction to Complex Numbers. In this video, we are going to discuss how to represent the given complex number in the complex plane, how to find its modulus, argument, and addition of two complex numbers, subtraction, product, and quotient of two complex numbers. Also, we are going to see how to represent a given complex number in polar form. Okay, see, z equal to x plus iy. This is the standard form of writing a complex number where this x and y are real numbers and this I is square root of -1. Okay, this x is called real part of z and y is called the imaginary part of z. So they are represented by RE of z, that is real part of z is RE of z and imaginary part of z is IM of z. Okay, so this complex number is represented in plane. So in coordinate geometry, we used to take x and y axis, no? So like that only here we are taking. So this horizontal line is real axis and this vertical line is imaginary axis. So here this z is equal to x plus iy. So the real part is x, no? So along the real axis you have to take x units and along the imaginary axis you have to take y units. Okay, so here this is x and here this is y. So this point is our z equal to x plus iy. Simply how we represent in coordinate geometry, no? In the same way we are representing it here. Okay, there we put x comma y, here we are writing it as x plus iy. That's all, there is no other difference. Okay, so this is the representation of complex number in the complex plane. Okay, so if z equal to x plus iy, if you have to find what is the imaginary part, you have to say it only y. Okay, what is the imaginary part means what? Y only. You should not say it as iy. Okay, y is the imaginary part. Right, next one is conjugate of a complex number. Conjugate is nothing but x minus iy, that is if x plus iy is the given complex number, then its conjugate is given by x minus iy. So where will you represent this x minus iy in the complex plane? See, this is positive real axis, no? And this side is negative real axis. And similarly for imaginary line, this is positive and downside it is negative, no? So x minus iy means it will come in the fourth quadrant. So here exactly if x plus iy is here, no? X minus iy will be here. So this is called conjugate of z. Now if you add a complex number with its conjugate, then what will happen? This iy plus iy minus iy get cancelled. So you will be getting only 2x. That is 2 into real part of z, which can be written as real part of z equal to z plus z bar by 2. Okay, and similarly when you subtract these two complex numbers, x plus iy minus of x minus iy, this x get cancelled and you get 2iy. Okay, that is 2i into imaginary part of y. So imaginary part of 2i into imaginary part of this one is not y, z. Okay, 2i into imaginary part of z. So imaginary part of z is z minus z bar by 2i. Okay, now let's see how to find modulus of a complex number. If z equal to x plus iy, then its modulus is given by square root of real part square plus imaginary part square. What is real part? X. So x square plus imaginary part is what? Y. Only y you have to take, don't take this I. Okay, so x square plus y square. This is the modulus. Okay, this is usually represented by r. These are standard notations. Okay, wherever you see r in complex numbers, that represents magnitude or modulus of the complex number. Okay, so if you square on both sides, you will get mod z square equal to x square plus y square, that is equal to r square. Okay, that is equal to r square. In terms of z and z bar, we can write it as z into z bar. Mod z square is nothing but z into z bar. Right? Where will you represent this r in the complex plane? See, already I have marked z here, no? Join this z with the origin. This is our origin O, no? So in coordinate system, how will you take? In the same way, this is the origin O. So join the complex number with this O. Then this is a line segment, no? The length of this line segment is the modulus R. Okay, and this line segment is making an angle theta with the real axis, no, and this theta is called the amplitude of the complex number, either amplitude or argument, in any way you can write. Okay, what is r? R is the length of the line segment joining the complex number with the origin, and the angle which it makes with the real axis is called the amplitude. So if z equal to x plus iy, then its amplitude or argument, it is written as either AMP or ARG. First three letters. Okay. Amplitude of Z is equal to, the formula is tan inverse of y by x. That is theta equal to tan inverse of y by x. So these two things determine a complex number in the plane. Okay. Next, let's see two properties of this amplitude which are similar to our logarithm. See, when you have logarithm of product, log of a into b, how will you write? Log a plus log b. And similarly, for log of a by b, it is log a minus log b. No, the same property holds true for amplitude or argument also. That is, amplitude of z1 into z2 is equal to amplitude of z1 plus, just for remembering this concept, I have written logarithm here. There is no relation between these two. Okay, just for remembering the result, I have written it here. Amplitude of z1 into z2 equal to amplitude of z1 plus amplitude of z2, and similarly amplitude of z1 by z2 equal to amplitude of z1 minus amplitude of z2. Okay, so let's see some examples. See, this is the first one. Let z equal to 2 plus 3i. So this is a complex number. So what is the conjugate? Conjugate is 2 minus 3i. Only for the imaginary part you have to change the sign. So modulus of z is equal to square root of, what is modulus? Real part square plus imaginary part square. So real part is 2, 2 square plus 3 square. So 4 plus 9 equal to root 13. Okay, so modulus z equal to root 13. Modulus of a complex number is always equal to modulus of its conjugate also, because what is its conjugate? 2 minus 3i, no? So if you take modulus, what will happen? Here also it will come 2 square plus minus 3 the whole square. But when you square minus 3, it will become plus 9 only. So modulus of a complex number and its conjugate are always equal. Okay, next let's find what is the amplitude. Amplitude equal to what? Tan inverse of y by x. Y is the imaginary part and x is the real part. So tan inverse of, for this complex number, imaginary part is 3. So 3 by 2. Okay, so this is the amplitude. Let's see how to represent this in the complex plane. So along real axis, you have to take 2 units because real part is 2, no? So 2 units, and along the imaginary axis, you have to take 3 units. So 2 comma 3. So it will be coming here. Join this with the origin. Then the length of this line segment will be what? Root 13. Okay, and this angle theta, amplitude is equal to what? Tan inverse of 3 by 2. Okay, and where will you represent this z bar? On the fourth quadrant. 2 comma minus 3. Minus 3 will be here only, no? So 2 comma minus 3, z bar is here, and this length of the line segment is also equal to root 13. Okay, that's all. Now let's see how to add, subtract and multiply the given two complex numbers. Suppose if z1 equal to 1 plus 2i and z2 equal to 3 minus 4i. For adding two complex numbers, you have to add real part with real part and imaginary part with imaginary part. So here real part is 1 plus 3 plus 2i minus 4i. So 4 minus 2i. Similarly for subtraction also the same thing. 1 minus 3, real part minus real part, 1 minus 3 plus 2i minus 4i. So it will be plus 4i. So minus 2 plus 6i. Okay, next one is product of two complex numbers. Z1 into Z2 equal to 1 plus 2i into 3 minus 4i. First, you multiply 1 3s are 3, 1 into 4i equal to 4i minus 4i. Next one, 2i into 3 plus 6i. Then 2i into 4i. So it will be what? Minus 8i square. But what is I square? I square equal to minus 1. So here if you put minus 1, it will become plus 8. So 3, 6 minus 4, 2i plus 8. So it's equal to what? 11 plus 2i. So this is the product of the given two complex numbers. Okay. Next one is how to find the inverse of a complex number. That is, if z1 equal to 1 plus 2i, what is 1 by z1? 1 by z1 is 1 by 1 plus 2i. Remember, whenever you have complex numbers, you should get that I only in the numerator. I should never come in the denominator. If you have I in the denominator, you have to do some simplification so that I gets eliminated in the denominator. For that, you have to just take the conjugate of the denominator. Here, what is the denominator? 1 plus 2i. What is its conjugate? 1 minus 2i. So multiply and divide by 1 minus 2i. So the numerator will be simply 1 minus 2i and denominator is like a plus ib into a minus ib. See, in algebra you have studied a plus b into a minus b equal to simply a square minus b square. It is in algebra. When you take complex numbers, the same formula is true here also, but here we are having I no a plus ib into a minus ib. So it will be a square plus b square. Okay. So here what is a? 1 and b is 2. So 1 plus 1 square plus 2 square. So 1 plus 4 equal to what? 5. So 1 by z1 equal to 1 by 5 into 1 minus 2i. So see, look at this one. So we don't have I in the denominator. So this is how you have to write. For irrational numbers also, you would have done like this, no? You should not have any irrational number on the denominator. For that, you will multiply and divide by the number, no? In the same way we are doing that, okay? Right. Next one is we are going to find z1 by z2. So what is z1 by z2? 1 plus 2i by 3 minus 4i. Again, as I told you, you should not get I term in the denominator. So for removing this I term, I am multiplying and dividing by the conjugate. So here it is 3 minus 4i, no? So it will be 3 plus 4i by 3 plus 4i. Okay, so now we multiply the numerator. 1 or 3, 1 into 3, 3, 3 plus 4i, then 6i plus 8i square divided by denominator, it is of the form a plus ib into a minus ib. So it will be a square plus b square. So 9 plus 16. So look at the numerator, 3 plus 10i. Here I square is equal to what? Minus 1. So minus 8. So 3 plus 10i minus 8. So it will be minus 5 plus 10i. Denominator it is 9 plus 16, 25. So throughout you cancel 1 5. So it will be minus 1 plus 2i by 5. So this is how you have to find the quotient of two complex numbers. See, here also you are not getting any I in the denominator. We have eliminated that one. Okay, right. Next, there is one more form of representing the complex number in polar coordinates. Polar coordinates mean in terms of r and theta. Already I told you what is r and theta. R is nothing but length of the line segment and theta is the angle the line makes with the real axis. With this one I am going to write the complex number z equal to r into cos theta plus I sin theta. Okay, or simply r into e power I theta. What is e power I theta? Cos theta plus I sin theta, no? So this is another form of representation of complex number. This will be very helpful for doing many calculations. So we use polar coordinates in some places of calculation. Okay, so if you raise the power to n, z power n, what will happen? You see this term, r power n into e power I n theta, no? What is e power I n theta? Cos n theta plus I sin n theta. So simply we can find in z power anything, okay? Whatever may be the power, we can easily write z power n equal to r power n cos n theta plus I sin theta. Okay, so how will you write z bar in terms of polar coordinates? What is z bar? X minus iy, no? So here it is simply r into cos theta minus I sin theta. Otherwise r e power minus I theta. So what is z bar? Z is r e power I theta. Z bar is r e power minus I theta. So when you multiply these two values, r into r square, e power I theta into e power minus I theta is what? E power 0. E power 0 is what? 1. So simply it is r square. Okay, now let's see one example. See, this is a complex number 2 plus 2i. Let us write this in polar form. So modulus of this complex number is equal to square root of real part square is 4 plus imaginary part square is 4. So it's equal to root 8. So this is the value of r. Then what is theta? Tan inverse of b by x, y by x. That is y is the imaginary part by x is the real part. So tan inverse of 2 by 2 equal to what? Tan inverse of 1 equal to, when will you get 1 for tan theta? 45 only, no? So theta equal to 45. So z can be written as root 8, that is r into cos 45 plus I sin 45. So this is a way of writing complex number in polar form. Okay. So few things that we have to remember here is every real number is also a complex number with imaginary part equal to 0. Okay. And regarding the conjugate, if it is a purely a real number, the conjugate of the number is equal to the number itself. Okay, because there is no imaginary part, no, it is equal to the number itself. So that's all. Thank you.